Good morning, one and all. I'm Babitha, working in Marri Laxman Reddy Engineering College in the ECE department. I'm going to take the lecture on Introduction to Testing and the problems considered in testing. So let us see the course content of this subject as well as the basic introduction to testing. The course contents of this syllabus are of this subject are course objectives, course outcomes, syllabus, introduction to testing, need for testing, and the problems in digital design for testing. So let us see the basic course objectives of this subject: test and testability. So the test and testability, the main course objectives of this subject, test and testability, are to provide or board understanding of fault diagnosis. So that is, to provide understanding of fault diagnosis is one of the course objective. To generate the test patterns using LFSR and CA, to illustrate the framework of test pattern generation, to design for testability for combinational circuits, to design for testability in digital design. These are the course objectives of test and testability. So the course outcomes of this test and testability are: on completion of this course, test and testability, we are going to analyze the testing challenges in analog, digital, and mixed signal circuits, along with fault models, and design for test strategies for reliable circuit performance. Examine test pattern generation techniques used in combinational circuits for improved fault detection. Design pseudo random test pattern generations using linear feedback shift registers and cellular automata. So apply design for testability techniques including controllability, observability, and Reed-Muller's expansion for enhancing testability in combinational circuits. Design testability sequential circuits using full scan, partial scan, and multiple scan techniques, improving fault detection. So actually, the course outcomes of this test and testability are: when we are by the completion of this course, you will be able to analyze what are the types of tests that we are going to do for testing the circuit, and for that how we are going to give the test pattern generations, how we are going to analyze the test pattern generations, how we are going to design the test pattern generations, and test a circuit so that it is a fault-free circuit for both combinational and sequential. And for those, we are going to see different techniques. For those are Reed-Muller's technique, as well as linear feedback shift register. With linear feedback shift register, we are going to design the test pattern generations. So this is the syllabus for the subject. Unit 1, need for testing, problems in digital design for testing, and problems in analog and digital, the problems in mixed analog and signal, the fault in digital circuits. This the first one covers the basic introduction on how to test a circuit, what is the need of testing a circuit, and all the basic information on testing, and what are the basic fault models in the testing. The second one comes the how to design test patterns. So how to design test patterns, what are the manual test pattern generations and the automatic test pattern generations. For that, we are going to see the different algorithms like Rhodes-D algorithm, and we are going to learn the pseudo random test pattern generations. We will try to generate test patterns with pseudo random. So before going for this is the syllabus for the test pattern generations and how we are going to design the test pattern. So this is the introduction for the test and testability syllabus course content. Now let us see what is test and testability, what is the subject, what is meant by the subject, as well as what is it actually what we are going to do in this test pattern in this subject. Test and testability. By the name itself, we are going to test. So in this test and testability, you are going to design the test pattern generations. We are going to try to design. So why we are going for testing? So testing is when you're trying to design a circuit. It is, this is in digital circuit, so that is in VLSI. So I'm going to give a brief introduction on how we are going to test one single circuit. Example, okay, when we are going to design a circuit, for example an AND gate. When you are going to design an AND gate, when we are going to say that the circuit is not working properly, when if you test one sir if you test if the output of that circuit is not proper, then we can say that the circuit is a faulted circuit. So when for an AND gate, if we go for an AND gate, so the for designing an AND gate, we need two input AND gate. We get four combinations: 0 0 0 0 1 0 1 1 0 and 1 1. So this is a combination of the output of this combinations is 0 0 0 and 1. So this is the proper output of the AND gate. If at all we get the wrong output in the sense 1 1 1 0, if at all we get the output as 1 1 1 0, we may say that the output that we got is the wrong output. So hence the design is wrong. So the designed circuit may be wrong. So when we say that a circuit that is designed is faulted circuit, based on the different options, like for example, if the output of the circuit is wrong, we say that the circuit is a faulted circuit. So in such a case, the input combination that we are writing over here for an AND gate is, for a two input AND gate, we are getting four combinations of outputs. So in this test and testability circuit, what we are going to do is, we are going to generate this input combinations, so that the outputs that we get is, we check the outputs based on the given inputs, and then we are going to identify that whether the circuit is a faulted circuit or not. So over here, for a two input AND gate, we got four combinations. For a two input AND gate, we got four combinations. The output of this, we can directly say that the output is faulted or not. But if you are what we are going to see, but if at all, if we are going to increase, if at all we are going to what we say if at all we are going to if at all we are going to increase the input combination. For example, this is a two input AND gate. If at all I want to generate a four input combinational AND gate, how many number of combinations I may be getting? 2 power 4, that is 16 combinations of inputs I have to generate for this. So 2 power 16 combinations I can generate manually, and I can test it. Over here, what I want to say is, I can generate for 2 power 4, 2 power 5, 2 power 6. In case if I want to design any circuit that is more than more than 10 or 15, that much combination of output we cannot generate manually. So that is the problem in designing, in testing. So the main concept is problems in testing. Now when I'm trying to design a circuit with n combinations, so I may not design to that n combination test patterns. So over there, in order to generate the input test patterns, I may be getting a problem. So that reflects in my design. Along with the specification. So over here, we in this concept, when you are trying to test a circuit, we are giving some input combinations. Based on the outputs, we check. Over in the AND gate, we have seen, right? So in an AND gate, you are generating some inputs, two input combinations. AND gate you are giving for circuit under test. Okay, we are giving AND gate for the circuit under test. For that AND gate, you are generating some test patterns. Test patterns are the inputs. inputs that you are giving. Inputs, we are giving some 4 type of input combinations, 0 0 0 1 1 0 and 1 1. These combinations are given to the circuit under test. That circuit under test, the outputs of this circuit under test, whatever the outputs we are getting, those outputs will be verified whether the output is correct or not by the test circuit. Okay, by the test circuit. And if at all the outputs are correct, then we get the information that the circuit is working properly or not. So in order to generate these in this subject, we are going to read what are the test patterns that you are going to generate, what are the algorithms what we are using to generate these test patterns. And when once you are giving that test patterns to the circuit, so what happens, that output, how you are going to compare that with the previous outputs. So in this is one of the problem that we have that is arised, that is the number of combination of inputs that you are going to generate. For example, for a 2 input AND gate, we are getting 4 combinations. In case if you are going to increase the number of combinations, there we will face a problem in digital circuit. So in that is one problem. The other one is comparing. So this comparing, so the 4 combination of outputs test comparing is okay whether the circuit is working properly or not. But if at all we are increasing the number of combinations, so those total number of combinations, we cannot compare each and every combination, so that we can try to we can check whether the circuit is working properly. In such a case, what happens is the design the production of the design will be more when compared with the design of a chip, design manufacturing of the chip. So so in order to overcome that, what we are doing is we are trying to give some number of output combinations. So for while generating these number of while generating these number of test patterns, then outputs of these must be particular outputs will be assigned, so that if those outputs are proper, then we will say that the output the circuit is working properly. So this is what we are going to see the different different problems that arises in test pattern generation. So the next one is for example, another example, if we take for another example of a circuit, if we are going to take, what happens is for example, if you are going to design an adder, for an adder we need sum is equal to a plus b. Half adder I am going to take, half adder I am going to design. Adder will be equal to sum is equal to a plus a XOR b, and carry is equal to a and b. So if at all the output that is sum is 0 0 0 1 1 0 1 1, and then sum and carry will be my outputs. If at all I give this half adder as a half adder generation, these test patterns I will generate using LFSR. We are going to see in the test, that is LFSR. So with the help of LFSR, I have generated these 4 combinations for an half adder. I got these 4 combinations. So sum will be 0 and carry will be 0. The sum will be 1. 0 plus 1, the sum will be 1. Sum will be 1, carry will be 0. Sum will be 1, carry will be 0. Sum will be 1 and carry will be 1. So based on these outputs, I can say that the circuit is okay. The circuit is fault free circuit. So over here in test and testability, whatever the terms that we are going to see is faulted circuit or fault free circuit. Fault free circuit we are going to see if at all the circuit is fault free. If you don't find any faults, we say that it is a fault free circuit. And here these over here, these are the test patterns that you are going to generate. These are the different terms that we are going to see in test and testability. Test patterns, along with this fault free circuit, over here we got the output. If at all we get this output as if at all we get this output as if at all we get these as the outputs, we say that it is a fault free circuit. If there is any change, that is if at all I get sum is equal to 0 and carry is equal to 1, I say that this is a faulted circuit. faulted circuit. So this type of fault circuits also, we have different fault circuits. So what are those fault circuits? Let us see. So if at all the circuit is occurring at 0th place, that means if the circuit that is stuck at 0, then we say that it is stuck at 0 fault. Stuck at 0 means if the output that you are getting is based on the input combination of 0, if the output that you are getting wrong, that is based on the input combination with 0, then we say that it has a stuck at 0 fault. If it is stuck due to the if the output is wrong because of the one output, we say that it has a stuck at 1 output fault. So in this we have seen so in this lecture we have seen what is testing and what are the different types of testing, what are the different along with that we have seen an example of how we are going to test a circuit, what is the need for testing, along with a digital diagram. So this is one of the diagram how we are going to test a circuit. So this is a chip level design based on the specification. This is a VLSI design flow based on the specification and the architectural design, whatever the functional design, logic, circuit, physical, fabrication and testing. So this is the physical VLSI design flow for any device. Example of an AND gate we have taken. If you are going to design an AND circuit, what we do is we need the first thing is we need the specifications. Based on the specifications, we are going to design an AND gate. So as we have taken the 2 input AND gate example, so if at all the specification is given as 2 input AND gate, so that is the system specification. Now the architectural specification will be there, where we are going to design the architectural design that is based on the truth table and all those. For that and all those where we go for logic design, circuit design, functional design, these two comes under truth table. From there, based on the logic, based on the truth table, we are going to design a logic diagram. From there we go for the circuit diagram and the physical design. Later we get the finally comes the fabrication work. The need for testing is when we are going to design or manufacture one single chip, we are going from through all this process. So when once finally after designing, if at all we find any problem in the chip, and that is a faulted chip where it is being not used, over there what happens is the complete production will be a failure. So instead of designing everything complete, after the complete completion of production, if we find that it is a faulted, so there will be a complete loss of the manufacturing. So instead of because in order to overcome that problem, what we are going is we are going for the testing. So in that testing, we have seen an example of a digital circuit where we are going to design a 4-bit AND gate and how we are going to test that. So how we are going to test that. So this is the flow chart of how we are going to test. So chip design activity is included, and over chip design activity is included. From there, if at all for wafer fabrication, this is the OEM and vendor vendor explanation. So based on the vendor and the specification, we are going to design. So if at all the circuit is okay, then it will go for the next stages. Otherwise it will again reach to the previous step, and the complete process will take place. So the chip design and activation, OEM and vendor, according to that wafer fabrication will be done. In case if there is any fault, if it is not okay, it will go to the previous section. Otherwise we will go for package and prototype function checking, and if that is okay, we will go for the incoming chip, or else we will go back to the previous one. So this is what we do testing and the problems that arises in testing, and a small example of how we are going to test the circuit. So this completes the lecture on test and testability, lecture 1 on test and testability, and let us see the next lecture on how we are different types of faults in test and testability, and what are the how we are going to find the stuck at faults and stuck at 0 faults and stuck at 1 faults. Thank you.